Cloud Native Postgres one-on-one.
Yeah. Let's go. Hi, everybody. Let's start. My name is Gabriele Quaresima. I am a staff software development engineer in EDB. So, yeah, there is a list of things I like and love. But, yeah, let's start with a survey. How many of you use Kubernetes? I think anybody in the room. We are on a KCD event. How many of you knows about Kubernetes operators and use them? Okay, I can skip some slides and save for the demo some time. And how many of you use PostgreSQL? Wow. Other slides, I can skip. And how many of you use PostgreSQL on Kubernetes? Wow. Nice. Didn't expect this. Okay. So, yeah, let's start to talk about CloudNativePG. CloudNativePG, starting from January, is a CNCF sandbox project, and it is an open source operator designed to manage PostgreSQL workloads on any kind of supported Kubernetes cluster. And he defines a new case results called cluster. Again, it's an abused word, cluster. And this represents a PostgreSQL cluster made up of a single primary and a number of replicas, usually 2 replicas. So yeah, a bit of Postgres, but you already know Postgres, as you tell me. So yeah, it's one of the most famous object relational database, and it's been around about 29 years. So yeah. One of the most important things in Postgres are the features, and there is a lot. I'm just reporting some from the documentation. And also the extensibility is one of the point of strength of Postgres. And actually, developers love Postgres. From surveys, this is well known. And yeah, Kubernetes operator, you know everything, as you told me, but yeah. Basically, there is a user that modify a custom resource that the operator is watching and interact with the Kubernetes API in order to align what the user specify. So, yeah, what are Kubernetes operators? They are software extension to Kubernetes. They rely on custom resources that you define and follow Kubernetes principles, obviously. And obviously, they follow the control loop. Yeah, they also implement and automate activities, and you can start to abstract your whole logic with this custom resource, so you do not interact directly with Kubernetes object, but with this new layer of abstraction, the custom resources that you define. So this is another little schema that show how it works. And the operators basically, you can have levels that they should adhere. CloudNativePG is actually a level 5 operator, so basically it do any of these: basic installation, seamless upgrades, full lifecycle, monitoring insights, autopilot. The operators are very, very important for many reasons, and also you can write to your one, choosing your SDK, choosing your language. You have a lot of possibilities. And this perhaps is the most important slide. So basically, CloudNativePG is built on the shoulder of giants. So we have Kubernetes and Postgres, and we try to bring Kubernetes people to use Postgres because we love Postgres, but also do the opposite, to bring Postgres user to adopt the cloud, and also CI/CD, DevOps mindset, and what the cloud brings together. So let's talk about CloudNativePG. So this is the simpler, a cluster CRD example, the easiest one. So basically, you just define the name, the number of instances, and the size of the storage. You don't even specify Postgres parameters or whatever. There would be some nice webhooks to do this. So yeah, this is the most easy, the most simple manifest. This is kind of the suggested architecture, because you can define how many replica you want, but by default you have a primary node, a PostgreSQL primary pod that inside a node, and then you have some replicas, 2 replicas, and also there are the services, the read-write services for the primary that is shown here, but also the read-only services for the replicas. CloudNativePG directly manage the persistent volume claim, so you don't have any stateful set. It creates a persistent volume claim for each PostgreSQL instance with the goal of storing the PG data, and it mounts it into each pod. The container storage interface for PVC also allows us to build some interesting feature, like a volume snapshot backup and restore. And also, you can have the online resides, the persistent volume claim cloning. This is a short list of some of the main features of the CloudNativePG operator. So you can scale up and down. You have a self-healing for failover or even switch over. You can declarative manage the PostgreSQL configuration, but also we enforce declarative table spaces, databases, and publication and subscription. So basically, you can achieve logical replication in a declarative way. And also, a nice new feature is a major PostgreSQL upgrade offline. That is something that is always delicate to do. And thanks to the operator that do this for us, trying to be a better DBA than we can be. And also there is this new way to imagine and build the CloudNativePG operator like a core, and then you have a CMPGI, an interface. So you can define your own plugin to run together with the operator. So basically, you can write your own way to perform backup if you want. Why not? So yeah, this is one use case. This is a distributed PostgreSQL topology with a replica cluster. So basically, you can have a replica cluster switchover with this configuration. That is nice to have in this data time for AI. And also, we provide support for PG Bouncer in a declarative way through the Puller CRD. So in front of the pod, we have this layer. How can you install CloudNativePG? You can install from the manifest or from the helm chart, or if you are on OpenShift with the OLM. There is no operator without operands, so operands are very, very important. We build directly from the PG/DG supported version, so that CVs are addressed, and also we maintain a Postgres extension for our images, and there is a nice blog article from one of the maintainers about how you can build your own custom container image. The observability is something very important. All the logs are in JSON format. We also offer a plugin for the kubectl, and in which you can gather some more info. I will show you in the demo this status command, gathering some data about your cluster. And also you have the Prometheus exporter, so you can attach a Grafana dashboard like this one. You have also this in a repo beside the main one. In the CloudNativePG project, there is also the Grafana dashboard. This is a screenshot about the plugin commands. You can also hibernate or fence the cluster. So basically, you can shut down gracefully Postgres and debug, or you can remove all the Kubernetes and debug Postgres. This is the latest slide I added because I want to add something. Also, from my perspective, what I like and love about this project. So I love the massive suite of end-to-end that run in our pipeline, the documentation, my colleague, the team members, and also the community enthusiasm. And this picture shows, the demo of the project pavilion at the last KubeCon, where the maintainers were on the stage. CloudNativePG is production ready. We have almost 6K GitHub starts, and again, I say again that is a CNCF sandbox now, project now. And also, it is completely open source. It has been created in EDB, but donated to the community with the Apache 2 license. We have a lot of important adopters and user like Google Cloud, Microsoft Azure, IBM, and also, some end users like Hitachi, EDB, Akamai, and so on. Beside the main repo, the operator, there are the Grafana dashboard, like I mentioned before, but also helm chart, CMPGI examples. So there is a lot of stuff. These are the useful links to reach us and to reach the project. So we are active in the Slack community. Now we are being moved the old Slack workspace into the CNCF one. There are 2 channels. And also some of the maintainers and the developers are part of the Data on Kubernetes community. That is very important, as you can imagine, for us. And so we also participate to the discussion to bring data on Kubernetes. And there is a lot of KubeCon talks. None of the one I mentioned here has been done by us. So it's from external people that start to compare database operators and use them and see how they work. So, okay, it's demo time. So I try to do, at least the first part. But let's see if we have some time to also do something else. Okay. So I have just built my local env in kind. So basically, I run this script to destroy the cluster kind, create a new one, and load and deploy the operator. So I have a fresh kind instance, a cluster kind, with just the operator deployed there. Can you see? It's bigger enough. You prefer bigger? It's fine. Okay. So let's start to see what I would like to apply. I would like to apply this simple manifest. I specify the image name because if I have time, I want to perform an image upgrade, a measure version upgrade. So let's start to apply this. As you can see, we have the status of the cluster saying setting up primary because, basically it's pulling down the images. So let's see how the Wi-Fi allow this pod to come healthy. Let's see if something is on the way. But pod initializing, the kubelet is pulling down the image for sure. Let me, running. Nice. But I would like to take this time, meanwhile all the 3 instances get ready and the cluster will be declared healthy by the operator. I would like to see actually what it is inside our cluster now, inside the resource. So I call the cluster Finland, as you see before. Let's see. Let's do some less because it is a bit bigger. So as you can see, we have a lot of stuff. We have, the image name, we declare it, and also the instances, but there are a lot of information. Also, all the default, the Postgres default that the operator enforces if you don't manage directly them. So yeah, there is a lot of stuff. We didn't set any backup for reason of time, but also with min.io, you can test it locally in a very smooth way. And here in the status, you can see there are some certificate, DNS name. So there is a lot of stuff. The PVC. So you can see there is, IRL at the end. Okay, let's see if our pods are up. Still the third one is on the way. Let me again watch the cluster to see finally at some point if we have this cluster healthy. Yeah, cluster in healthy state. Awesome. Let's start to use the plugin like I promised to you. So we have this CMPG plugin, and I can do something like this. So you can see the primary instance is the pod file-1, and also there are 3 instances. You have a lot of information collected with this command. So this is very handy. But let's see, there is Postgres here. So let's enter a pod and do something. See, Postgres 16.8 is here. Let me create a table, numbers. Let me insert a number just to see that it's working. Then I can see, I can enter a replica, see. If numbers is there, yeah, the tab worked, so it's there. Let me also create something here. Oh, I hit the wrong. Okay. We cannot create a table in a replica. So our services are working perfectly. So let me do something nasty. So let me start to kill the primary. So I like the command say the primary instance is Finland1. Awesome. Let's kill it. Let me do another thing. Here I want to get again the cluster. And here I want to kill my pod. So you can see failing over on the right. So we have this failover. The operator is self-healing the cluster. Cluster in healthy state. Let's see who's the primary now. It's Finland2. Awesome. Okay, let me do something. I want to show you a declarative database I want to apply to my Postgres instance. So I have this one. Database Helsinki. So this is again, naming is the hardest thing in computer science. So database is also the name of the CRD. So we have this object that is database Helsinki that specify inside our cluster Finland a new database named Helsinki. Okay, so let's apply it. Oh, what I'm doing? Okay. Some point we'll let exit. Okay. So let's see if the database is there, first of all. So yeah, even a replicate's fine. Let's see. As you can see, the second line there is Helsinki. Awesome. What I can do with that database let's get it. Get database Helsinki, DB Helsinki. So if you see, I want to show you something that the database enforces. There is this database reclaim policy retain, so that if I delete the CRD, the database will remain in Postgres. But I can edit this, and yeah, let's edit it. I want to specify a different database reclaim policy, like a delete one, so that once I've been deleted the object, also it should have been removed. I deleted the database. No, I edited. I edited. Yeah. Let's see if it is there in Postgres or not. Should not be there. If you see, in the second line there is no Helsinki anymore. Helsinki is gone. Okay. Sorry, it's always like this with this talk. It's not the first time I did this. Okay, let me show you something about the metrics. I should have a car metrics YAML. Yeah, it's just a pod to perform a car. Let me apply it. Let's see. Container creating, running, awesome. So let me do something. Let me exit here. So there is this command. I can do better. Let me cut this. Awesome. Then I can get the pods. So I need the IP address of the Finland one. Let's go for the master. Yeah, this one. So I can do this, and yeah, let me take it again. Awesome, should work. Yeah, I think I miss an S here. Oh, too much. Let me do something like this. So basically, here there is the collection of the Prometheus metrics that the operator shows, but you can extend this. So yeah, there is a lot of stuff. Let's see if I'm able to do a measure version upgrade. If we have time to pull the image with the Wi-Fi, let's see. Let me edit here. This should be fine. And we can see here that there is a new status, upgrading Postgres merger version, and it's continuing to perform all the operation. This is done via PG upgrade. So yeah, this is something that we should wait. Meanwhile, I come back to the slide. Let's see if I forgot something. No, I've been a good guy. All what I wrote here has been showed. So yeah, meanwhile, we are waiting for the new image to be up. Let me show you the last slide. And if you have any question, meanwhile it's going, please.
Do you know if there are any big production deployments done already with this one?
Yeah. The question is, do you know that there are already big production cluster with CloudNativePG? This is the question. Yeah, I know. I know.
You know, and there is.
Sorry?
You know, and there is.
Yeah. Let's see. Oh, okay. It's creating the second replica. So at some point, it will be healthy, hopefully. Any other question?
I have another one. So you stated that it has this level 5, so it has auto-scaling automatically done. So you just specify some parameters and then you can scale up in the replica.
Yeah, yeah. As you can see here, the operator knows the number of instances should be 3, and it scale up. So it's, yeah, this is something that has been done, I think, in day 1, even if this is day 5. Yeah, this is something that it is from the beginning.
Looks cool.
Thank you. Let me think.
Compared to the pricing of any cloud provider, SQL databases.
Yeah. Here, yeah. Oh, cluster in healthy state. He did it. So let me see if we have a new Postgres version, if I lie to you all the time or not. Yeah, it's 17.4. Yeah, that's it.
There's still room for a question or two.
Wow. No, there are 5. Okay. Okay. Let's start from you. The first one I saw.
All right. I saw there that for upgrading to the new version, all you had to do was to specify the new image.
Yeah.
How does the operator actually know what kind of image you specify for it? What if you specify something else than Postgres?
I specify a precise image from our open source registries, but if you build the image in the way that the operator can digest, you can specify whatever you want if you have access. Perhaps you need an image secret in the CRD, but basically it's not that you can upgrade only with my image. You can upgrade with your image. You are under control. Also, if you have some extension like PG Vector that actually is built with our base image, you know that if you upgrade Postgres to a major extension, you need also to take care of the extension. It is not so straightforward, but there will be a very, very nice feature in Postgres 18 that will allow you to configure a different folder for the extension. So we pushed for this, and this is the first time that in a PR inside PostgreSQL also CloudNativePG is mentioned as a user of this, a very big user of this, because this will easify the way we can deal with the images, with the operand images. Because I'm not 100% sure, but perhaps you don't even need to rebuild the image. Not sure, but it will easify for sure our process with the operand.
Thank you. Yes, my question is about
Currently, if you want to specify roles, you have section in the spec, but we are going also to do this in a declarative way and deprecate the old one. So it is in the roadmap. At some point, you will have all the pieces that you need to perform the logical replication and the Postgres upgrade, not only the offline, but also the online one. So step by step, we are arriving also there.
Okay, we're at time, so thank you.
Okay, we can speak outside. Thank you.